2 z particular equals, let me write this right. Hang on, hey, don't write that. All the way, yeah, no, let me do it that way. Z particular equals capital Z E I T plus pi over 4 with capital Z equal, and what did we have over there? 1 over, what did we have? Capital Z.
Square root of 2 over pi minus 1.
Okay, that was the square root of 2. Thank you. I minus 1. Now the change. Or now a second approach. Now, the second approach is write I minus 1 in exponential form. Okay, so let's do that together. So I always have to think about these. I'm going to draw that for a moment. Probably right at the edge of my counting. So let's draw this. When you draw your complex, and you represent a complex number, and we say to the complex plane, our horizontal axis is the real component, and the vertical is the imaginary component. And so let's see, my number is minus 1, that's my real component. That's over here. And then my imaginary component is plus 1i. That would be about there. So here's minus 1, and here is 1. So that's kind of wiggly looking, but that's my modulus. Should do it in blue. I'll highlight it in blue. There's my modulus. This is my we're going to call this lowercase r, because I've already used capital R. You don't want to, and your line should be straighter than that. And we're going to introduce another angle right here. This angle here, we'll call that alpha. Use theta again. Whatever you do is don't use theta twice. If you use theta over there, don't use it again here. Pick another symbol. All right, so remember, if z is some complex number is minus 1 plus I, then we have to find its modulus. Its modulus is what? You have a right triangle. Each side is 1, then the hypotenuse would be square root of 2. E to the I alpha, and we have to find alpha. And alpha, or tangent of alpha, has to be, give us a 1 over minus 1, or negative 1. So what do we get from alpha? Yeah.
Can you write the middle form of that down?
Do what?
The you write the general form for that jump, you just did from C to the what you call the modules.
Oh, how do I get to here?
Yes, you know, did you set up the general form for that? That's what we-
Yeah, it's this. Yeah, it's so, and no, okay, so let me do that. And where R is the square root of your, in this, in general, it would be the real component plus the imaginary component squared. So you could write it as, it's the real part of Z squared plus the imaginary part of Z squared. And in this case, the real part of Z is 1 squared, and the real part is it's negative 1 squared, and the imaginary part is 1 squared, and that's where we're coming up with the square root of 2. And what would alpha be in this problem?
That's not.
Yeah, and in radians, let's use radians, because we already got some radians, so let's just be consistent. 3 pi over 4, okay. Pi over 4. Now, look at what we've got. So our goal is write I minus 1 in exponential form. Okay, so that gave us, what is it? I minus 1 is equal to the square root of 2 e raised to the I times 3 pi over 4. Whew. Yeah.
Is alpha always pi minus the other end?
No. That would just be this problem. Because if we would have changed A, it would have been like if we would have at least they don't think so. True. I don't think that's yeah.
So that you define it saying you probably was in a circle, so the max out.
Yep, yeah, the angles work exactly as you expect. Good. Okay. Kind of running tight on space. I'm going to come back over here. Does anyone need a picture of that before I erase? This I'll leave up here. I'll leave that. We'll come back over here. So let's write what we found. Write what we found. Here's what we've got. We now have that Z particular is equal to the square root of 2, that's an equal sign, equal, square root of 2 over, what did we just write for a capital Z? We wrote down, it's really the square root of 2 over the square root of 2 e I to the 3 pi over 4. Square root of 2 e I to the 3 pi over that. Times, oh, we got the rest of this, e raised to the I times, what did we find out? It was t plus pi over. Okay. I know many of you have been trained not to cancel things with slashes, but I am just so excited that I can't help myself. I'm going to cancel those. Okay. I know. And not only that, but you might think, well, this just looks like a mess. But if you think that, then you forgot the beauty of exponentials. This is the basis match. So all you would do is subtract the exponents. And so what we have now is we really have, I'm going to write two steps. Remember, this e is in the numerator. So really I'm left with the problem of e I t plus pi over 4 over e I to the 3 pi over 4. And now we just subtract the exponents. So this becomes e raised to the I, and then, let's see, we've got an it, we've got a plus pi over 4. Oh, look at that, minus 3 pi over 4. So let's write that out. That's an I, t plus pi over 4 minus 3 pi over 4. So this whole thing cleans up. E raised to the I, t minus pi over 2. But we're not done. Okay, remember?
How did we get over there to the top one?
Oh, you know, I was thinking that. I think I got a little ahead of myself. We did all of this work. So capital Z can be written as the square root of 2. I'll write it out over. It was originally I minus 1, but now these are equal here. Square root of 2. Square root of 2 e I 3 pi over 4. And remember, we're using all of this work that we've already done. We're using this work right here. We're using this z, but now we're going to take a different route. And the route is remember, our answer is real. But that's not real. How would I find the real component of my answer? That's what we want. I hate to do that, but here goes. Okay, so